A little over a year ago, I undertook the challenge of, hypothetically, creating a Space Marine, using modern medicine to see how close we could get. For each of the 19 organ implants involved in the transformation process, I proposed a modern alternative that might be used to similar effect. Finally, today, we conclude our ongoing saga as Billy, the young Astartes aspirant, receives the final implants to become a full-fledged brother. In the battle to protect the Imperium of Man, nothing less will suffice. It doesn't look like the fighting will end anytime soon. Oh, and thank you to those of you who have been patiently waiting on this video. I know it's been a long time coming. Bring in the Mucranoid. The artwork for this organ, as well as those to follow, was done by the first Magelord on DeviantArt.com, whose work really enhances today's lesson. In phase 16, the Mucranoid, also called the Weaver, is implanted with the central nervous system in response to specific chemical stimuli in the environment, causing the Space Marine to secrete a waxy protein substance similar to mucus through his pores that seals his skin. This process can protect them from the harshness of the vacuum of space and other extremes of temperature, particularly deeply frigid environments. In trying to grasp the full potential of this implant, I came across this Reddit post. I am reading Predator Prey, and on pages 124 and 125, they describe 3 Space Marines that had secreted cocoons about themselves as a protective and healing layer. Well, this organ definitely earns the Weaver moniker. Now, according to Warhammer Wiki, the gland's operations must first be activated by an external chemical treatment, usually self-administered. Space Marines are cocooned in this way before they enter suspended animation. I'd imagine, as first suggested by the first Magelord, this could also be deployed to a lesser degree before doing battle in or near the vacuum of space. Like all the Space Marines organs, this is a tall task, but I dare not hesitate in the service of the Emperor. So, our sweat comes from specialized structures called sweat glands in the skin. When the body gets too hot, the brain, more specifically the hypothalamus, notices and tells these glands to produce sweat, a simple solution that is 99% water and 1% salt and fat. When sweat evaporates on the surface of our skin, it cools us down. Sweat, as described above, comes from eccrine glands, simple coiled tubular structures that are present most places throughout the body. These glands are not structurally equipped to produce any other form of solution, let alone a complex protective layer as with the Astartes. However, we have another type of sweat gland called apocrine glands, found mainly in areas with lots of hair. For example, armpits and the groin, which produce a thicker fluid which serves functions related to odor production, potential chemical signaling, and lubrication in areas prone to chafing. These functions are achieved through the addition of proteins, hormones, and extra lipids, or fats, into the apocrine sweat solution, while the gland itself is larger and more complex in structure than its eccrine counterpart to accommodate the change. Okay, we're getting closer. And as it turns out, other glands with even more complex function and structures have evolved from apocrine sweat glands. Both mammary glands, which allow women to secrete breast milk, and ceruminous glands, which produce cerumen or earwax, are considered modified apocrine sweat glands. Perhaps with a little genetic engineering, which I covered in detail in the first installment of this series, we may be able to alter the chemical composition of the solution produced by apocrine glands to achieve the desired function. Perhaps something somewhere between breast milk and earwax would suffice. Looks like our captain is a couple of steps ahead of us. A solution with nutrient density present in breast milk to aid in healing and restoration, but that clumps and dries with the thick consistency of earwax.
Breast milk, you made my day.
While many animals and plants can produce actual wax, the ceruminous glands in our auditory canal secrete mostly sebum, a secretion made of fat, skin cells, dirt, and sweat colloquially known as wax due to its similar consistency. Containing several types of fat molecules or lipids, sebum helps moisturize and protect the skin, possessing antibacterial components while providing some protection against light and helping to regulate the inflammatory response. This is starting to sound useful to the guardians of mankind. In order to achieve the mucranoid, a plan to rely on genetically modified apocrine glands working in tandem with a drug that ramps up sebaceous sebum secretion. Generally, androgens are known to affect sebum production, though other hormones may do this as well. For our purposes, the chemical cocktail administered prior to mucranoid cocooning will contain various hormones. We've got one last problem to contend with. Apocrine glands only live in our nooks and crannies. And since modifying the ubiquitous eccrine glands to produce a biologically advanced protective substance is akin to asking a preschooler to play Bach's most difficult concerto, we've got quite the surgical procedure ahead of us. While technically sweat gland transplant surgery is possible, it isn't easy or practical in normal applications. But since nothing about this is normal and no surgery off limits, the attending apothecary will replace, let's say, 10% of the ecrine sweat glands throughout the body with the genetically engineered apocrine counterpart. Well, 5% of 2 to 4 million, and yes, we have that many ecrine sweat glands, is approximately 100 to 200,000 microsurgeries, where each surgery would require the connection of tiny blood vessels and nerves that supply the glands. This would be like a modern hair graft procedure, but performed all over the body at once. The pain would be bad, and the recovery process is very, very uncomfortable. But hey, anything is possible at the behest of the emperor. Bring out the Betcher's gland. Out of context, I know, but I had to find some way to include a clip from Syama Peterson's incredible Astartes animation. Here, another excellent Mage Lord drawing depicts the poison synthesizing organs which are implanted into the mouth in phase 17 of the Space Marine creation process. Two identical Betcher's glands are introduced either into the lower lip alongside the salivary glands or into the hard palate where they synthesize and store deadly poison, which the Space Marine can spit at enemies if necessary. You know, like this. Because an Astartes can never have too many deadly abilities. So what exactly is venom, and is there anything similar to it that already exists in the human body? Well, it turns out animal venom is a complex mixture of various proteins, peptides, enzymes, and other bioactive molecules, components that the human body is in fact capable of producing. While venomous animals produce proteins or enzymes that target and damage specific life-sustaining structures, humans do not. For example, a protein or enzyme is considered neurotoxic if it interferes with nerve function, leading to paralysis. Hemotoxic if it destroys red blood cells and or disrupts blood clotting. Cytotoxic if it damages cells and tissues, leading to pain, inflammation, and necrosis at the site of the bite. And cardiotoxic if it affects the heart, leading to cardiac dysfunction and potentially fatal outcomes. Get the idea? During my research, I stumbled across an interesting article entitled, "Could Humans Ever Be Venomous?" New research reveals that humans do have the toolkit to produce venom. In fact, all reptiles and mammals do. The study's co-author, a doctoral student in evolutionary genetics at the Okinawa Institute of Science and Technology in Japan, named Agnieszka Barua, says, essentially, we have all the building blocks in place. Now it's up to evolution to take us there. The findings of Barua et al. Suggest repeated co-option of shared molecular machinery for the evolution of oral venom in mammals and reptiles, blurring the line between truly venomous animals and their ancestors. Which is to say that the venom systems, as they are called in the article, in venomous animals literally use pre-existing biological structures in the body to produce the requisite toxins. Sounds like a job for protein or enzyme engineers. Yes, this field currently exists. Let me explain. Consider the concept of neurotoxicity, whereby a toxin impedes the function of affected nerve pathways. There is no hard and fast rule by which the toxin achieves this goal. Neurotoxins are not all the same. Some block nerve cell channels, causing paralysis. Some target the places where nerves and muscles meet, causing muscle weakness, and so on and so forth. So, a specially designed enzyme might target and destroy a specific compound in order to achieve one of these results. The job of the protein engineer would be to alter the design of an existing enzyme by changing the shape of its active site, which is basically a pocket on the surface of the enzyme, so that the active site readily binds with a specific chemical or substrate in the target. When the enzyme binds to a target molecule, a chemical reaction occurs, which in the case of enzymatic or protein-based venom has destructive effects. Like a seemingly stranger asking for a hug while secretly wearing an explosive vest.
I accept these burdens, knowing no fear.
Nothing our apothecaries can't handle. Earlier, we already established that apocrine sweat glands are capable of both protein and enzyme production and secretion, and that they are capable of evolving into more complex structures. Were we to weaponize the enzymes within an apocrine gland through protein engineering, then transplant these glands into one of the suggested locations, we'd be in business. But even though a venom of this type may be theoretically possible in humans, it isn't exactly the face-melting acid carried by our Space Marines.
Why are you so filthy? He spat on me.
You see, toxicity is an overarching term that encompasses a wide range of substances, including both highly acidic chemicals and enzymatic toxins. But only acid of the face-melting variety will appease the emperor. As it turns out, offensive toxic compounds that work purely based on their high acidity are less common in animals, where most poisonous creatures use protein-based toxins we just discussed. But you know what they say, when presented with a difficult problem, go with the gut. No, really. The human body actually produces various types of acids as part of normal physiological processes, one of which is hydrochloric acid, or HCl, which is produced by special cells contained in the stomach lining. Hydrochloric acid helps to break down proteins and kill potentially harmful microorganisms in ingested foods. Sounds familiar. It is also corrosive to the eyes, skin, and mucous membranes, which is why we are equipped with several mechanisms to protect ourselves from stomach acid, including a mucus layer, bicarbonate secretion, a basic solution that counteracts the acid, tight cell seals, and a constantly regenerating stomach lining. Internally, the production of the HCl is limited to a manageable pH within the 1.5 to 3.5 range, with a concentration of 0.5% to 1%, or 5,000 to 10,000 parts per million. In industrial settings, more concentrated acidic solutions of 1.1 pH with up to 35% concentration is used for various applications. The lower the pH and higher the concentration, the more dangerous the acid. So, if we could turn off the systems that regulate HCl production, we could increase these factors. Let's say we extract the stomach from a donor, carefully reduce its size to create a small pouch, and genetically impede functions that limit HCl productions. We'll have our acid spit. Crude though they may be, we then implant these pouches into the cheeks of our Space Marines, allowing the soldier to bite down on their cheeks to release the poison manually into the oral cavity. They're already immune to everything, don't worry.
I accept these burdens.
Plenty of space in those cheeks.
Hey, yo!
Voila! Spit acid, melt faces. Of course, the innervation and blood vessel vascularization of these structures would be incredibly challenging to achieve surgically, and our Space Marines would be left looking like a squirrel preparing for winter. It's a price I'm sure they're willing to pay. Up next, we have the progenoid glands, a pair of extremely important organs implanted in phase 18 of the creation process, upon which Space Marine reproduction is dependent since they carry the DNA for all other organs involved. Sounds like it deserves a video of its own. Thankfully, I have you covered. We covered the progenoid glands and their feasibility with modern medicine in our first ever video on this topic. Go ahead and cue that one up for a refresher later on. And now, get ready to tackle perhaps the most distinctive implant of all, the black carapace. Also known as the interface, this neuroactive thin black material is implanted directly under the skin of the neophyte's torso. According to lore, the material hardens, and invasive synthetic fiber bundles that will serve as connection points for neurons grow inward and interlink with the newborn Astartes' central nervous system. In this incredible animation, made some 9 years ago by Erasmus Brosdo, we see the black carapace protrudes through the skin in several areas. Brosdo accurately depicts the numerous connection points or holes cut through the carapace by an apothecary. That allow a Space Marine to directly interface his central nervous system with his power armor's cybernetic systems. To my understanding, it is the black carapace that enables a Space Marine to use his power armor to its maximum capabilities, as well as other vehicles, making it feel as though he is part of the machinery he is operating. It should be noted that there is another fibromuscle layer involved in the armoring process, but that is beyond the scope of today's video.
Sheathe my form in the second skin. This veil of machine muscle and false nerves.
This depiction does portray the neural bundles, or wiring, that connect the power armor to the black carapace beneath the skin. Shown here along the length of the spinal cord. Technically speaking, the power armor plugs directly into an extensive subdermal, or subcutaneous, both terms meaning beneath the skin, brain-computer interface that doubles as a thin layer of armor. Modern brain-computer interfaces such as Neuralink or BlackRock's Utah Array have demonstrated that it is possible to both send and receive signals to and from the central nervous system. So we're off to a good start. Here, a monkey named Pager controls a game of Pong with his mind.
Neuralinks allow Pager to play his favorite video game. To control his paddle, Pager simply thinks about moving his hand up or down.
But as incredible as these systems are, our progress with brain-computer interfaces is elementary compared to the advanced capabilities of the black carapace. Still, the basic mechanism of action would likely be similar. Think about how the central nervous system works. Our CNS, which includes the brain and spinal cord, relies on electrical impulses for communication. The electrical impulses that we send and receive throughout the system can be interpreted by man-made electrodes, simple conductors through which electricity enters or leaves an object. These electrodes can send and receive information and may be placed at various points in the central nervous system depending on their purpose. Now, motor neurons are a specialized type of brain cell located within the spinal cord and the brain. They come in two main subtypes: upper motor neurons, which originate in the brain and travel downward to connect with their counterpart, lower motor neurons, which send signals out towards the associated musculature. The spinal cord is the information superhighway that enables communication between upper and lower counterparts. Since the black carapace sends tendrils throughout the body, we can conclude that it is connecting with both the upper and lower motor neurons at once. There are some advantages to such a widespread system, which we'll get to in a moment. But in the modern world, this would likely need to be hardwired through extensive and very invasive surgical procedures. Wherever you want the tendrils to go, you'll need to cut a path for them. Although some modern BCIs, like Neuralink, have the capacity to use Bluetooth, I doubt that such technology would suffice for a Space Marine in the heat of battle. Formidable enemies would literally think the Bluetooth away. So modern Astartes can look forward to having small bundles of electrodes and associated wiring implanted throughout the body. At the very least, in the brain, along the spinal cord, and at important neural junctions in the chest, abdomen, and extremities. Theoretically, so long as the hardware remains intact, a Space Marine might be able to retain function even if their innate nervous system is severely damaged. To some degree, this has been demonstrated in real life.
You've been able to take the electrical signals which represent his thoughts and use that to control stimulation of his arm and his hand.
Here, Black Rock, Utah's array, BCI, is bypassing irreparable damage to the spinal cord by restoring the link directly between upper and lower motor neurons.
It really got good. One day they had some mashed potatoes. Lo and behold, I was able to eat the mashed potatoes really well.
You have to understand. Normally, when a spinal cord is severed, its role as information superhighway is compromised, and all function below the level of the injury ceases. So the restoration of normal function is literally miraculous.
I'm still wowed every time I do something amazing. I ate a pretzel. I drank water.
Can you imagine the possibilities as we begin to master this form of technology? Theoretically, our Marines could have a functional backup nervous system that could operate independent of a large portion of their biologically innate system. Excluding the brain, we haven't figured out how to replace that yet. What's even cooler is how such a widespread system would integrate with the power armor.
With pride, I wear the symbol of my chapter.
Since the carapace is directly connected to a Space Marine's brain via electrodes, it receives thought information before that information is converted into actual movement. During normal biological function, while thoughts are translated into movement incredibly quickly, a fraction of a second, this is still a process with several steps. Electrical impulses travel through neurons in the brain, down the spinal cord, to our lower motor neurons, and eventually to the muscles. This process only feels instantaneous to us because the brain compensates for the slight delay. Are you still with me?
Barely.
A form of advanced synthetic wiring could transmit electrical signals faster than the CNS is capable of doing so, which means, one, the power armor receives the impulse to move before the musculature naturally does, creating a sensation where the armor almost anticipates the Space Marine's movement a fraction of a second before it occurs. And two, the carapace tendrils transmit the impulse to move directly to the motor neurons before they would arrive naturally, which means the Space Marine is both moving faster than they could before and being moved by their power armor faster than the speed of thought. Sounds like it might take some getting used to. But as you might imagine, in the Astartes line of work, every millisecond counts. Now, if we can decide on a suitable material for our modern black carapace, we're off to the races. Whatever material we choose must not interfere with the important biological functions carried out by the skin, which, by the way, is the largest organ in the body. After all we've done, this may seem trivial, but alas, the skin plays a vital role in maintaining homeostasis and, well, keeping us alive. Aside from its obvious role as a protective barrier, shielding sensitive tissues from physical harm, pathogens, and UV radiation, the skin regulates body temperature by sweating to cool down and constricting blood vessels to retain heat. It also houses sensory receptors, allowing us to perceive touch, temperature, and pain, and even contains immune cells that help combat infections. In order to facilitate these processes, the skin is a porous multilayer organ replete with blood vessels and nerve endings. At first glance, the black carapace may look like solid sheets or plates, but anything completely non-porous would compromise the aforementioned functions in the skin. I propose a composite material made of a strong synthetic polymer, such as carbon nanotube reinforced composites or advanced ceramics, and a permeable biocompatible matrix, such as hydrogel, that will enable the carapace to enmesh with living tissue once implanted. While hydrogel is currently being used to develop 3D print synthetic organ implants,
you're looking at a 3D bioprinted lung-mimicking air sac built using living cells.
As suggested in this Seeker video that features research carried out by Dr. Jordan Miller and his team at Rice University, the beauty of this material is that it can be combined with living cells in order to increase biocompatibility with the whole host organism. We can get pretty specific in this regard. Hypothetically, if we plan to implant the black carapace plates underneath the final layer of the skin, that is to say the hypodermis, but above the muscle layer, we might choose to incorporate cells that could encourage the plates to enmesh with the hypodermis above them. We would incorporate them both into our hydrogel solution, as Dr. Miller did with the cells corresponding to lung tissue in their experiment. Which means that something like this is, well, hypothetically possible. Well, Billy, a few more incisions and time enough to allow those black carapace plates to graft themselves to your flesh, and we're in business.
I am doomed.
Well, interns, we've got a full-fledged Marine on our hands. Does that make us apothecaries? And now that we've addressed all 19 of the implants involved in the creation of a Space Marine, would anyone like to volunteer for a trial run?
I volunteer! I volunteer!
We're only some 29,000 years ahead of schedule. From my understanding, the first founding was in the 30th millennium. Moving forward, I'll be open to covering more Warhammer 40k material.
That sounds fun.
Due to their added implants, I know the Primaris Marines could use their own episode.
Right?
But let me know in the comments what other grimdark lore you're itching to explore from a modern medical standpoint. Remember to join me at Human 2.0, my online gym for free, right here on YouTube, where we help you move better and prevent injury. If you liked the video, be sure to give it a thumbs up and subscribe to the channel. If you didn't, be sure to let me know why in the comment section down below. Otherwise, as always, that's been a word from Dr. Chris, not your everyday ortho, where we see one, do one, teach one.